Hello friends, welcome to our channel Aha Zindagi Edu-Care. In this lecture, we will discuss some important results on subsets. So, what are the important results? See, first one is every set is a subset of itself. So, if we have to prove this, that every set is a subset of itself, how we can prove this? Suppose A be any given set, let A be any set, okay? So we can clearly observe that each element of set A will be contained in A itself. Okay. So each element of set A is clearly in set A itself. Okay. Itself. So we can say that A is a subset of set A itself. Okay. So every set is a subset of itself. Next theorem is the empty set is a subset of every set. Okay. So suppose we have two sets. How we can prove this? Let A be any set and we denote empty set by phi. So phi be the empty set. So empty set will be a subset of every set. When this will happen? When every element of empty set is an element of set A. Okay, so then we can prove as we know, as we know. See, phi is our empty set and it has no elements. We denote like this. Okay, empty set. It has no elements. As we know that phi contains, phi or empty set contains no element. Okay. So every element of phi, so every element of empty set or phi, every element of phi is in set A. Okay, so we can say that empty set is a subset of set A, as set A is any set we have considered. So empty set is a subset of every set. Okay. Next theorem is the total number of subsets of a finite set containing n elements. Okay. So total number of subsets of a set containing n elements is 2 to the power n. So how we can prove this? So here we need to use binomial theorem and combinations. Okay. So you need to be aware of that topic also. Suppose A be a finite set containing n elements. Let A be a finite set. So what is a finite set? Finite set has number of elements which can be counted. Okay. So A be a finite set containing n number of elements, containing n elements. Okay. Now let R is such that R is less than equal to n and greater than equal to 0. Suppose a set has n elements and we choose to form subset containing suppose r elements or suppose 2 elements. Okay, so r is that number of elements we are considering out of n elements. So we may consider forming sets with 0 elements, then we may consider forming sets with 1 element, with 2 element, and so on. Okay, so r will vary from 0 to n. So what will be the number of subsets containing R elements out of n elements? Okay, the number of ways, the number of ways in which R elements, in which R elements can be chosen out of n elements is NCR. It is a formula of combinations. Okay, we can write clearly NCR. That is, we are choosing R elements at a time out of n elements. Okay, so R will vary from 0 to n. Okay, so total number of subsets will be, therefore total number of subsets is equal to, see, when R is 0 it will be NC0, plus when R is 1 it is NC1 plus NC2 and so on, and R will vary up to n, so NCN. Using binomial theorem, we can find the value of this. We have to use binomial theorem of 1 plus x to the power n. Okay, and substituting x equal to 1, we can find the value of this one. Okay, so using that, it will be 1 plus 1 to the power n, and it is equal to 2 to the power n. This we have got using binomial theorem. Okay, so this is how we can prove this theorem. So this is about theorem 3. Next, we will solve a problem based on our discussion. So in this problem, two finite sets have m and n number of elements. The number of subsets of the first set is 56 more than the total number of subsets of second set. So difference between the number of subsets of first and second set is 56, and we have to find the values of m and n. So how we can do that? So let A and B be two sets having m and n elements, having m and n elements respectively. Okay, so number of subsets of set A, number of subsets of set A, as per theorem we have discussed, it will be 2 to the power m. Okay, and number of subsets of set B, it will be equal to 2 to the power n. Okay, and difference between these two is given as 56, given 2 to the power m minus 2 to the power n equal to 56. Here m will be greater than n, so when we will take common 2 to the power n, it can be written as 2 to the power m minus n minus 1 equal to 56, and we can find the value of m and n using heat and trial method. So this can be written as 8 into 7. Okay, so this will be 2 to the power n and 2 to the power n minus 1. Okay, this m minus n is in power. Okay, and this equal to 8 minus 7, so we can write here 2 to the power 3 into 2 to the power 3 minus 1. Okay, it will be 7 and this is 8. So from this we can get n equal to 3 and m minus n is 3. As n equal to 3, so from here we can calculate m equal to 3 plus 3, that is 6. Hence, value of m and n, m will be equal to 6 and n equal to 3. We have to find m and n values, okay? So in this lecture, we have discussed some important results on subsets and also solved some problems. Okay friends, thank you.